Thank you. And also welcome from my side. And very lucky that so many people are in this talk. It's a very dry topic. Documentation most of the time it's a bit underrated. And I hope I can show you some best practices and some cool tools which will help to write better documentation in the future. I must apologize. I'm from Germany. I think you can hear it, and my English is a bit rusty. I hope it will become better in this talk from minute to minute. So my name is Falk. I'm from my company is Embark. It's a German-based consultancy for software architecture. We are doing trainings and architecture reviews and such stuff like that. If you have questions, please contact me later if you have more questions. So let's start with the topic. And it's about 2 years ago, I saw this tweet on, in that time it was still Twitter, and now it's called X. And this guy, I don't know him. He said 2 years ago, docs as code, also architecture as code, so things like as code are currently at the beginning. And I must say, I know this topic already since 10 years about, or more, maybe more than 10 years. So I would disagree that it was in the start, or it started 2 years ago. But what he also said in this tweet, in this message, he said that the idea behind docs as code is to embed architecture documents in your Git repo. So put all your documentation, especially about architecture, in the same in the same place where also your source code on your software system is living. And that's kind of the core of documentation as code, and we see some more in a few minutes. So let's go or let's talk about what this talk is all about. And I have two main topics. One is to tell you a bit about docs as code, and I have some maturity levels which I want to share with you. We see the details in a few minutes. And I also want to present some tooling. And I must confess that some of the tools are from the Java world, because I'm a Java guy. I'm also Java champion and do a lot with Java. But I think it's about architecture documentation. So most of the tools are agnostic. So you could also use them in other environments in this .NET world or in the JavaScript world. But maybe the step is it's a bit huge step, because it's in the Java ecosystem. So yeah, I hope it's fine, and maybe you can also see, or you can find some tools in your ecosystem which are doing the same. And I want to inspire you with my talk, and maybe, yeah, depends from where you are and what are you doing in your day-to-day job. So let's start with a short motivation about architecture and architecture design. Most of the time when we design a software architecture, then first we have to gather all the requirements, the architecture goals, the quality requirements. And based on that, we have to make decisions and have to choose our strategies, our solutions, our technologies. We have to split our system in parts, in modules, in components, and so on. And when we look a bit deeper, then on the left-hand side, there are topics like quality goals, like constraints, like system context, or it's on the top, let's say, or something like mission statement. I won't go in the detail, but maybe you already know some of these topics. And on the right-hand side, there was the solution strategy. There's something like we have to decide about architectural style, about patterns, principles. We have to make decisions, and we have to also to document decisions, like in ADRs, architecture decision records. Maybe you have heard about it. We won't cover this topic here. And we also have to decide which technologies with programming language we want to use. And we can make something like an informal overview picture where we can put all that together in a big diagram where we can have a good starting point for new colleagues which join our project. And there are some examples. Actually, it's only in German, but if you understand German, we have on the web page of Embark. There you see this link on the bottom. There you find some useful flyers about different software architecture projects. For example, this one is about the Corona Warn app. It's a German Corona Warn app, or I have another one. Maybe you can see it here in front of my face now. It's about Freema. That's a messaging client. It's based in Switzerland. So just go to this web page, and then you can see some concrete examples how we document the content of a software architecture, which is important, which have to be documented, and we have this kind of flyer, which is quite nice. But that's not the topic of this talk. We have to go further. What are the tasks of a software architect or of the people who are doing software architecture, like the agile developer? And this image here is from a book from Gerhard Starke, and he says that we first have to clarify these are also, of course, the functional requirements, are also the non-functional requirements, the quality goals. Then we have to design our architecture, then we have to communicate it, and then we have to evaluate the architecture if it fits our needs. And there's nothing about documentation in this picture. But that's not true. There is documentation, because if we want to communicate our architecture to the other stakeholders of our project, then we have to document something. And we find lots of excuses why we don't like to write documentation. This is not a real book cover, but I think most of us think it could be true. And there are lots of really good reasons to have documentation. Documentation helps us if we design, so it supports us with the architecture design. It also is important for the communication part, and afterwards we have to review our software architecture to evaluate it, and then it's also important to have something we can rate about it. It's also very important when new colleagues join our team, and they have always this question, why did you it this way, and why did you not do it the other way? And it's very difficult if we can't say why we have done it in that way, for example. So the problem with architecture documentation, or documentation in general, is that most of the time we use the wrong tools. We have a break in the tools we have to use, because most of us, I think so, for me the case, are developers, and we like our IDE, our integrated development environment, like IntelliJ or Visual Studio Code. And for documentation, we have to go to Word, we have to go to, for example, to Confluence or other wikis, I don't know what it's called in English. We see it later. And maybe we also have to use file shares. No, it's not very modern, but maybe it could be. We have lots of redundancy, so a lot of informations are redundant in our code and also in the documentation. We have lots of text in our documentation, so most of us, it's more difficult to create images, to create pictures and or diagrams. We have to do a lot of manual work. For example, if we have a software release, we have to also to publish our documentation, and then you have to do some manual work to get it done. Maybe documentation gets very fast outdated, and then there's a problem that nobody reads it anyway. And then, why should we write documentation anyway then? So let's look at my maturity levels I brought with me. There's the level 0 on the bottom. That's quite easy. It's the traditional documentation, which maybe is we use WYSIWYG tools, or what you see is what you get. It's this abbreviation. So tools like Word, or tools like PowerPoint, or tools like Visio to create images. A few years ago, we stored our our documents on network drives. Maybe now we put it in the cloud, in SharePoint or whatever, but it's still the same problem. And we always separate our documentation from our source code. So that's not really a problem, but I think the other way around would be much more easier for us to write documentation. And of course, we use lots of wikis. And there's a little joke. I don't know if you know this fairy tale. It's famous in Germany. Most kids know this fairy tale. There's the hedgehog and the rabbit, and they make a race, and the rabbit thinks he is very fast, and the hedgehog can't be so fast. But when he comes to the finish, then the hedgehog is already there. So the idea is the hedgehog has his wife with him, and she is at the finish, and he's at the start, and the rabbit don't recognize that I lose my words. They do some tricks with him. So that's like me. Everywhere where I go, Conference is already there. So Conference is that wiki which is most companies use, and it's quite famous at the moment. So it's always used for documentation and also for architecture documentation. But I think it's not the best place. I also like wikis. I also like Conference, but I think it's not the best place. This guy is Ward Cunningham. He invented this concept of wikis, and this site on the top, it says wiki is the place where documents go to die. Or there's another joke, wiki could also stand for where information kills itself. I think that's not that false, because it's kind of true, because when you put some information in the wiki, then it's quite difficult to get the information out again. And you can search for it, but if it's not that easy to find the right information again. So I think we should think about if we can do better than put all our documentation in a wiki. So let's start with our first level, also first maturity level. And the first level, it's a bit small. I hope you can see it. It's about lightweight text formats. And also, you already saw it, we have to put the documentation, save the documents in our code repos like Git or wherever. And there's another German joke. I don't know if you can understand it. The German ones, of course, will understand it. There was this advertisement a few years ago on the streets, and LaTeX means in German condom. I think you know what LaTeX is. LaTeX is also a text format, scientific text format, or used by scientists. But in German, we use also LaTeX as a synonym for condoms. And this advertisement was about use condoms, so you don't get affected with AIDS or whatever. And when I saw this advertisement on the streets, I first thought, the main thing is you don't do it with Word. So when I studied at university, when I was at university, I tried to use Word for my master thesis or something like that, and it didn't work because Word was not ready enough 20 years ago. So it was a pain to work with Word, and I used LaTeX then, and it worked very smooth, and I really like it, but it's too complicated for me now. But I must remember, I had to remember when I saw this picture. So what are the problems with Word? And not only Word, also other what you see is what you get tools. It's a binary format most of the time. It's very difficult, for example, to merge if you have conflicts, two people edit the same file, for example. It's most of the time sent by email if somebody wants to share the current state of his document, and then you have very many Word documents on your mail server. It's kind of history, but it's not the right place for history, I think. And Word is also page-oriented, and that doesn't fit every. It can fit, but it mustn't fit for every architecture documentation. And it's also quite cumbersome to use subdocuments to modularize your documentation and also use image references and so on. And actually, our daily bread and butter as a developer, and I've already said it, I think most of us are from the development side. So maybe some of you are developers or maybe coding software architects, and then our daily bread and butter is plain text. So source code is plain text. We use tools like an IDE, and we only want to use one IDE because we like it, we use it every day, and we are very familiar with it. We also use lots of command line tools, and we use a version control. And if with this information in our head, let's go back to documentation as code. What does it mean? We have to put our documentation documents close to the source code. We store it in the same repository or maybe another repository next to it. We can therefore versionize it and can make a very easy diff between different states of my documentation. We can also synchronize deliver my documentation with my software. So if we release a version 3.2 for my software, we can also synchronize deliver the documentation for 3.2, for example. We also have offline capability, like when we use Git, for example. So if we use a version control system which is distributed, and that's, I think, a big advantage about the wiki, which is not offline capable, in my opinion. Maybe there are some solutions, but that's not that easy to use. It's also easy to put the process of generating the documentation. So we have some text formats and we have to generate a PDF or a Word file or whatever. It can just be part of our already existing build process. And therefore we can also automate it very easily, and we can generate informations, or we can use some informations from our source code or from also, for example, from our data model or whatever, where information come, and can generate some documentation from it. So we don't have to be redundant with the information. And we have some very flexible output formats. For example, I already told you we can have a PDF, we can have, for example, Word, we can also export it to Conference if it's necessary. We can also generate some slides. Sorry. We can also have some slides, not PowerPoint slides, but real JS, for example. So what about the markup languages? And the question is, which markup language we have to choose? Most of us know Markdown because we use, for example, GitHub, and GitHub didn't use Markdown in his README files, for example, for a long time now. And Michael Simmons, it's a friend of mine, he said a few years ago, yeah, it's fine. It's Markdown is all he needs, and he don't need some more tooling. But Markdown has some problems. So it's a lot of features which are provided by Markdown, but there are some missing features which are not provided in the standard of Markdown. And of course, there are some extensions or plugins you can use, but they are very different extensions, and GitHub uses other extensions and then other server software, and so it's quite cumbersome. And I think the better alternative to Markdown is AsciiDoc. And Ralph, also a friend of mine, answered to Michael a few years ago on that Twitter thread, yeah, but AsciiDoc is much more better. What is AsciiDoc? AsciiDoc is quite old, but it became famous a few years ago again because there was a new implementation. It's called AsciiDoctor. So AsciiDoctor is actually the interpreter of the format AsciiDoc, and it's a very powerful syntax for technical documentation. AsciiDoctor is written in Ruby, but there are possibilities to use it also in JavaScript or in the JVM, in the Java platform with JRuby, for example. And ASCII-Doc is only one standard. There are no dialects, there are no extensions, so it's quite easy to use it on different places. It's always the same. And a very easy process to get some information which are written in ASCII-Doc and put in a Git repo, for example, to to generate a PDF or HTML page. We can just use on the command line our ASCII-Doc tool, and I will show you some more tooling which is more sophisticated and is very easy approach. And advantages of these features to use Markdown and of course ASCII-Doc is, for example, that we can write documentation like emails, so it is distraction free. And we also can use something like sub-documents, and we can restructure our documents according to the different stakeholders. And we can also very easily reference images. We can also use diagrams as code. We will see a bit later. We can very easy version it. And we can also use source code and embed source code, or actually we link to source code, and we can format source code. And we can do very easily reviews, pull requests with GitHub or other tools. And we can convert it to HTML5 or to DocBook or to PDF or whatever we have to convert it to. That was the maturity level 1. And now we go further. The next maturity level is I suggest that you should use a standard structure for your architecture documentation. So it's more easily for the readers to find their way around, and also for writers, which get some orientation. And if they switch projects, then they are familiar already, because maybe there's the same template which you use the old and the new project. And there are some nice rules for good documentation from this book. It's from the Carnegie Mellon University, from the Software Engineering Institute, which is quite famous for for books and other publics about software architecture. And there's one rule number 4, which they say use a standard structuring. And what is a standard structuring? For example, Arc42 is one. Arc42 is very famous in the German-speaking spoken countries. So there's an alternative I will show in a few seconds. But what is Arc42 about? You can also use it in English or in other languages, so it's not only for German. Arc42 is like a cupboard where each of these cases is the place for one information. So it's a lot of it's a structure with a very simple, easy way to put your information in the special places, for example. And if you are already familiar with architecture documentation, then most of these topics, which are on the blue text here, so should be familiar to you. So like we have to document requirements, we have to document constraints, we have to document system context, we also have to document our solution strategy and so on. And there are different templates from Arc42, for example, for Word, but that's not in a good way. I think we should use ASCII-Doc or Markdown. There are also templates you can just download with all the headers and sometimes also with some description. And then you can just fill in your information from your project, and then should be quite easy. But it's more familiar for the German-speaking peoples, or because Arc42 was invented by Gernot Stark and Peter Ruschka, 2 Germans, or Peter Ruschka is from Austria, I think. But there are different views, and maybe you have heard about Simon Brown. He wrote some books, for example, about software architecture for developers, and also a book about visualizing, documenting software architecture. And from this book, he created another kind of structure. It's called C4 model. And I think you already heard about it because it's quite famous. And the for C stand for context. So it's a context diagram. Then for containers, components, classes. Containers, components, classes are different layers of our building block views. So it's also kind of a 4+1 view model. Maybe you've heard about it, so we won't go deeper here. And here's also beside these static building block diagrams, he also has some dynamic content like runtime views or deployment views or whatever. And it's another kind of structure. So maybe if you don't like Arc42 or you have never heard about it and you don't want to have a look at it and just have a look at C4, so it's nearly the same, but from another person. So it's some different ideas. And I think a very important part, and you can do it with Arc42, we can do it with C4, and you can of course do it with something like AsciiDoc, and the AsciiDoc tooling is that you have to modularize your documentation, because if you have one document with 50 or hundreds of pages, then it's quite difficult to maintain it and to read it and to print it and whatever. And of course, if you have different kinds of stakeholders and they are not interested in all the parts of your documentation, then it's better to have some smaller parts and to recombine them. So maybe you have some Arc42 master AsciiDoc file, which references or includes, is the better saying here, different chapters, chapter 1, chapter 2, chapter 8, whatever. And of course, chapters or these kind of documents can include also images, or can include source code, or can reference source code, and also it can include sub-documents. And now we have different stakeholders. For example, you have something from business, kind of business analyst or product owner, which is only interested in chapter 1 and chapter 2. Then you can write a new master file, which only includes these 2 chapters, and you have maybe a security master, which only includes the chapter 8.1 as the only information. So you can generate different output files for different stakeholders. So I think that's very important, because it makes it easier to maintain, to read, to write your documents. And these documents, these AsciiDoc files and these images and whatever you need is just on your file system. So you can just use the console, the command line, or your file tooling, what you use for your day-to-day job. And you don't need in Confluence search for documents which are in different layers of Confluence, wherever you can't find it. And it's much more difficult than just search on a file system and have some file or folder structure, which is, in my opinion, very, very easy to maintain. So let's come to the next level. And the next level is also quite interesting. I call it diagrams as code. And we already saw that we can include images. And therefore, I meant binary images like JPEG, PNG, images in binary format. And the problem is we have to maintain these images. And most of the time we have to use something like Visio, where we have in different format. It's a vector graphic application. And then we have to change something. Then we have to export it to a PNG or a JPEG file. And then we can include it again. It's quite cumbersome to use normal images. So let's see how it could work to write images, to write diagrams like code, so in text style. And that also reduces the risk for vendor login, and makes, because it's text, it makes graphics and diagrams versionable. And of course, you can make a diff between different versions, and it can read it as a developer and see, the difference is just one interaction between person A or actor A and system B or whatever. So what about diagrams? Diagrams, there's one diagrams as code, very famous tool. It's called PlantUML. blend-UML, you can very easily embed it in AsciiDoctor. There's a plugin extension for AsciiDoctor. AsciiDoctor is the interpreter of AsciiDoc format, which is called AsciiDoctor Diagram. And there you can just include or embed your blend-UML diagrams in your AsciiDoc files, or you can also put them in separate files and can reference them. And how does blend-UML look like? I have a very simple example here. It's a sequence diagram, and I think that shows the powerfulness of blend-UML. Of course, it's a bit more difficult to write very big or to generate very big diagrams, because it's most of the time it will be generated if you change something, and then the layout may change because it's an algorithm which resizes and recreate the image. That won't happen with a sequence diagram, because sequence diagrams are always read from left to right and from top to bottom. So sequence diagrams, I think, are the most easiest way, or for sequence diagrams, blend-UML is the most easiest way, and it works most of the time very good. But you can also use blend-UML for different kinds of diagrams. I have another example here. It's a bit more difficult. And you see then it becomes a bit more cumbersome to maintain this and to generate or to create bigger ones. And I would suggest then that you use blend-UML for the more smaller diagrams. And I think you will have lots of smaller diagrams, because we should we shouldn't use very big diagrams, because they are very hard to read, and they're also very hard to create and to keep it up to date, for example. So if we have smaller parts, then we can also use blend-UML, because it produces some very nice results, I think. And beside blend-UML, there's lots of more diagrams as code toolings, like DITA, which is a kind of ASCII art, or like the dgraph, which are different use cases why you should choose these tools about or before blend-UML, for example. And I have another tool which I want to show you. Maybe you've heard about it. It's a very cool open source project. It's called Croki. Croki is a server which you can just use this URL on the left bottom left on this slide here. And when you go there, then there's a kind of preview where you can just write down your diagrams as code, and Croki understands different kinds of tooling. So he understands, of course, blend-UML. He also understands a dialect of blend-UML, and it's called C4. So it's for C4. And there's also another format. It's called Mermaid.js. It's I think it's more in the Python and .NET JavaScript world. So that's can also use it. I have never used it because I'm a Java guy, and I like to use blend-UML and AsciiDoc, but there are different tools which also may fit for you. And so I would suggest to just try Croki.io, and there you have a long list with all the formats they understand, and you can just try them. And for example, blend-UML, they have their own webpage, blend-UML.com, where you have more examples to just see how powerful blend-UML is, for example. But I think Mermaid.js and other tools have similar examples, so that should be no problem at that moment. And if you have concerns about Croki.io, because it's a public server and you put your secrets of your architecture documentation to Croki.io to generate your documents or to generate your images, your diagrams, then you could also install Croki.io as a Docker file, Docker image, for example, or whatever. I've only heard about Docker. And you can deploy it in your own internet and intranet, and so there no information will go out. So that would also work. So let's come to the next level. And we have only 10 minutes left, so let's speed it up a bit. Tool integration is the next level, and also content generation to generate content and don't duplicate content, for example. And I already showed you this very simple workflow with ASCII Doctor a few slides before, where we can generate PDFs, HTML5. We put our ASCII doc files, for example, in Git, and we can also use a ARC42 template, for example, and then we have this ASCII Doctor interpreter with some plugins like Blend UML diagram plugin or PDF plugin to generate. And this kind of workflow is very easy to configure. You only need command line, or you can also use some build management tools like Maven, like Gradle, but you can also use it standalone, so that works. And we will see some more examples a bit later, but let's have a look at our normal day-to-day tools, our bread and butter tools. And this is our text editor. Most of the time it's a IDE. In this example, I have IntelliJ. And the nice thing about IntelliJ is that it supports most of these formats like Blend UML, like ASCII doc, and other formats with, for example, syntax highlighting, and also with some code completion, and also with code completion file also from the file system, and also with code completion with some special, or I think it's like a variable, and also with some structure where you can see how your document is structured, and also with some, you can open and close some kind of topics, and you have some live templates, for example, and so on. And also in IntelliJ, and I think that also works for other IDEs like Visual Studio Code, for Eclipse, and maybe others, I don't know, is the integration of tools like Draw.io. Draw.io, sometimes it's also called diagrams.net, is a vector graphic software, and it's written in JavaScript or TypeScript, I think so. It's with Electron framework, and you can just use it standalone on your laptop or on your computer, but you can also include it, for example, in Confluence. Maybe you've seen it there as a plugin, or you can also include it, for example, in IntelliJ. And then it's quite easy. You have some diagrams where you can't use Blend UML, for example. I already told you the smaller ones are fine, the bigger ones are a bit more complicated, and maybe then you have to use some graphic tools like Draw.io or diagrams.net, but you can also use Visio or whatever. And in that case, you can just use the same tooling, the same IDE, where you write your source code, where you write your ASCII doc documentation, where you also can write your Blend UML diagrams as code. You can also sketch your diagrams in vector graphic tooling like Draw.io, sorry. And Draw.io has some very nice feature. I don't know if you have heard about it. They can save the content of your vector graphics in the metadata of the image file, so of the JPEG PNG. And then you can just save your file as a PNG or JPEG image, but you can still open it again to edit and change some parts. And you can save it again as a binary format, and then you can just embed or reference the binary format in your ASCII doc file, for example. And so you don't have to export it and import it again, or have to look for where is the original file, which I have to edit, then to export the PNG, JPEG again, and so on. So that's a very nice feature. I've never seen it anywhere else, but I think it's not exclusive for Draw.io, but they use it very extensively. So we saw this very simple process workflow for ASCII Doctor, and there's a very interesting tool which also use the simple workflow, but put some more plugins around it. It's called Doc Toolchain. It's the main maintainer is Ralf Müller on one of the Twitter threads a few slides before. And he started this project, I think, 10, 15 years ago. And there are lots of other contributors which help him to improve this tool. You see on the left-hand side, there are lots of different kinds of import formats, for example, for Enterprise Architect, for Visio, for PowerPoint, for Excel. And we also have, for example, Excel, XLSX sheets, and also can import Jira tickets and so on. And what this tooling is doing, they import it in your ASCII doc documentation. So they try to read the information. Sometimes they just do some screenshots, for example, from the PowerPoint presentation. And then you can just import or embed or reference these images in your ASCII doc documentation, which is based here. So that uses this ARC42 or C4 template or whatever. And then the ASCII doctor workflow translated to PDF, HTML5, DocBook, Pandoc, Real.js as a presentation. And there's also an export to Confluence. Sometimes you still need to export it to Confluence because you have some business users which only can read it in Confluence or whatever. So that's a very, very interesting tool. So if you have never seen it before, I really recommend to try it out. It's very easy to use. You can just go to the web page doctoolchain.org, and there's this small script or small example. You have to use wget and download a wrapper file. It's called DTCW. It's called doctoolchain wrapper. And then you make this file executable, and then you can just use it. It uses there are two ways it works. On the one hand, it uses just Docker. If you have Docker installed, then it's quite easy. On the other hand, it has to download all the stuff. So it also needs Java because it uses Cradle. Cradle needs Java. So it's a bit more difficult, but if you have Docker, then it's very easy to use. And if you try these 4 lines in your command line, then you get a very a full project created with the ARC42 structure, for example, with some examples which you can just put your stuff in and build your own documentation. Okay, let's come to the next level. And the next level, and that's it's about feedback and continuous improvement. There's also a rule in this book. You saw this list of 7 rules for good documentation. And rule number 7 says you have to check your documentation for usability. So you have to get some feedback if the documentation is usable. And it's a process I call continuous documentation. And it's a bit, it's nearly the same as in our software development processes. Where we also have a continuous feedback process, continuous process where we want to get better and get feedback and become better developers and get better software and so on. So the parts of continuous documentation is that we have to automate our documentation, to creation of our documentation. Then we can deliver it regularly with each release of our software. Then we can, of course, continuously supplement it, can make reviews, and can integrate the feedback again. And that's a workflow which we can do all the time. And actually, we can use the same workflow as we use as a software developer, where we do, for example, code reviews, where we make pull requests in Git. And we need some colleagues which check if the commit is fine. And then they maybe give us feedback or they merge the pull request. And I can do it with the same tooling. And if I have to do some code reviews, and I could also check the documentation if it changed and when it changed, fine, or do we have to rework some stuff. So let's come to the last level, and the last level, which is a very small one. Actually, it's a very big topic, and we would need more time in an extra talk. It's called executable documentation or living documentation, and it's about having a documentation which is lively, where we have rules for our software architecture, which we can execute. Tools for it are JQ Assistant, ArcUnit, or X Molecules, and there are some more. But these tools are also working for different programming languages. So it's also in Java, popular in Java, but also working for C#, .NET, C++, and so on. And I already showed you lots of toolings, but let's recap it. So we had toolings in IDEs, text editors, we had toolings for build management, we had toolings with the formats, the standards, and also for diagrams. And I've put all the toolings I showed you, or most of them I showed you, on this slide. So let's go the last 2 minutes. I'm finished in a few seconds, in a few minutes, see what it is all about. So if you use your IDE, then you can also easily write the documentation in your IDE, for example, with these plugins, where you can embed your Draw.io in Visual Studio Code or in IntelliJ, for example. When you use build management, then you can, of course, use this very, very cool doc tool chain. When you use lightweight formats, then I would suggest to use ASCII doc, but also Markdown would be fine. And of course, use something like a standard structure like ARC42 or, of course, C4 or whatever. And if you use diagrams, then have a look at Croki and see all the different kinds of diagrams as code tools like PlantUML, Mermaid.js, and whatever. Have examples there and try it for you. So that's all. I hope you enjoyed my talk and a little small summary. There was a voting which are problems in open source projects, and the first or the most important answer was incomplete or confusing documentation. So it's for open source projects, and I think that don't have to be, because the Docs Code approach makes it very easy to write documentation, and also for open source projects. So we've seen there's documentation as code, but there's also continuous documentation. There are lots of different parts, and most of them I showed you, like the text formats, like a bit talked about generating content. I talked a lot about images, diagrams. I talked a lot about Docs code and continuous documentation. And the last level was the execute, validate part, the executable documentation. It was very short. And the last simple here, the caretaker is needed to somebody of us should be the caretaker in your project to look that the documentation is in a good shape. So that's all from me. If you want to see this the slides, you can just download it from the web page. It's actually only in German, but you can also write me an email. And we have a training company behind us. It's called SoCreatory. We offer lots of training, so please have a look there. And here are my information. So you can reach me at fs@embark.de, or you can also follow me on Twitter or Blue Sky or whatever. And thank you for your attention. And if you have some questions, I think we have some time left to can I have a look at the chat, or thank you very much.